In this problem, we are asked to conclude which of the following statements can be used to show two angles are congruent to each other. The reflexive property of congruence can be used to show that two angles are congruent. Let's say that we have this big purple triangle, and within the big purple triangle, we have a smaller green triangle that shares this angle that I'll mark in orange. So two triangles that share the same angle, we can apply the reflexive property of congruence to say that that angle is congruent to itself. The definition of midpoint cannot be used to show that two angles are congruent. This is used to show that two segments are congruent only. The definition of perpendicular bisector can be used to show that two angles are congruent. Let's say this orange segment is the perpendicular bisector of the purple segment. We know that the orange segment hits at the midpoint. Additionally, we know that because of perpendicular, we have right angles formed at this intersection. So those green angles that I have shown right there are congruent to each other because right angles are congruent to each other. The definition of segment bisector cannot be used to show that two angles are congruent because we are taking a segment and cutting it into two pieces. Therefore, we're getting two segments are congruent, not angles. Definition of angle bisector can be used to justify that two angles are congruent to each other. So if we have an angle and it is bisected by a line or a ray, we can say that these angles are congruent to each other. Vertical angles are congruent can be used to justify that angles are congruent. Vertical angles are formed by the intersecting segments or lines. They share a common vertex. So we could have a set of vertical angles that are opposite of each other here, or we could use this set. Our last two statements use the parallel lines cut by a transversal. These can be used to show that special sets of angles are congruent to each other. Our first type is alternate interior angles. These make the Z or the N. So when we have our parallel lines cut by a transversal, we have our alternate interior angles that we know are congruent. We also have the corresponding angles, and these make the F. So we have several sets of those. We have this one and the one top and bottom. We have another one below this. And we have one more set in this other corner. So we actually have four sets of corresponding angles that are congruent.